Exoplanets are planets that orbit stars other than the Sun and thus exist outside the solar system. The word exoplanet derives from the term extrasolar planet, which hints at its existence beyond the influence of our star. Prior to the 1990s, humanity had never observed a planet beyond the solar system and thus could not confirm such worlds existed. In the more than 3 decades since the first discovery of an exoplanet, as of 2023, the exoplanet catalog contains over 5,500 confirmed exoplanets and almost 10,000 additional candidate exoplanets. Exoplanets that orbit in the so-called habitable zone, the region around their star where it's not too hot or too cold to sustain liquid water, are targets for the search for life outside the solar system. The life survived depends on the exoplanet. The chances of life existing on an exoplanet are significantly greater if that planet exists in the habitable zone of its star. Astronomers are also currently becoming aware of the possibility of Piscean worlds. These planets are dominated by liquid oceans and could hang on to liquid water outside standard habitable zones, thus widening the potential area around a star in which life could exist. Currently, the closest exoplanet to Earth is Proxima Centauri b, which orbits the star Proxima Centauri, located 4 light-years away. The crew-carrying module of the Artemis missions is Orion, which, Lockheed Martin, has a top speed of 24,000 miles per hour, 39,000 kilometers per hour. That means that traveling constantly at this top speed and assuming no diversions, it would take Orion over 1 billion hours to reach Proxima Centauri. That's more than 114,000 years, so until the invention of light-speed travel or suspended animation, it is not possible to travel to an exoplanet. Over 5,500 exoplanets have been discovered so far, with a further 9,900 suspected exoplanets awaiting confirmation. All this has happened since 1992. So these numbers are likely to change frequently. One thing that has become abundantly clear in humanity's exploration of exoplanets is that planets come in a much wider range of categories than can be seen in the solar system. While our planetary system hosts a relatively ordered system of terrestrial planets, like Earth, gas giants, like Jupiter, ice giants, like Neptune, and dwarf planets, like Pluto, exoplanets are more diverse and more disordered. Hot Jupiters are gas giant exoplanets that orbit close to their stars and complete a full orbit in just a few Earth days. The hot in hot Jupiter refers to the proximity of these planets to their star, which can lead to searing surface temperatures. The Jupiter in the name refers to the fact that these worlds have sizes and masses that are most comparable to Jupiter's, though they can be many times more massive or just a fraction of its mass and size. The proximity to their star can cause hot Jupiters to puff out to huge diameters while making them incredibly light in terms of density. Some of the lightest exoplanets ever found are hot Jupiters. Hot Jupiters' size and proximity to their stars also create greater effects on these stars, meaning they are easily seen using the radial velocity and transit methods. This means the exoplanet catalog is heavily and disproportionately weighted in favor of hot Jupiters. There is nothing like a hot Jupiter in the solar system, and some evidence suggests that these planets may form farther out, like Jupiter and Saturn are in our solar system, and then migrate closer to their stars. Hot Jupiters overlap with the following categories of exoplanets when examples of these worlds are found close to their stars. Terrestrial exoplanets are roughly Earth-size worlds outside the solar system that are composed of rock, silicate, water, and carbon. The bulk composition of these worlds is dominated by rock or iron, and they can have either a solid or liquid surface, according to NASA. A deeper investigation of these exoplanets is required to determine if they have atmospheres or oceans. Perhaps unsurprisingly, as Earth is the only planet we are aware of that hosts life, these worlds are the major targets in our hunt for life beyond the solar system. Super-Earths, alternatively known as mini-Neptunes, are planets that are up to twice the size of Earth and have up to 10 times the mass of our planet. meaning they're larger than terrestrial planets but smaller than ice giants and gas giants. Super-Earths don't necessarily have to be terrestrial planets. They can be gas giants. Neptune-like exoplanets, or Neptunian exoplanets, are worlds similar in size to Neptune and Uranus, around 4 times the size of Earth and around 17 times its mass. Neptunian worlds are thought to have mixed interiors but heavy metals at their cores. Neptune-size worlds are a mystery for astronomers because so few are discovered close to their stars. This lack of hot Neptunes, with orbits of around 4 days or less, has come to be known as the hot Neptunian desert. One suggested reason for this could be that if planets don't have a lot of mass, the radiation from their stars easily strips their atmospheres, thus quickly turning potential hot Neptunes into super-Earths. Rogue planets, also known as isolated planetary mass objects and free-floating planets, are worlds outside the solar system that are not gravitationally bound to stars. That means that they wander the Milky Way alone without a parent star. One possible explanation for rogue planets is that they form in planetary systems and are then flung away by gravitational interactions with other planets in the same system or by encounters with another star system. A less plausible, but still viable, formation mechanism is that rogue planets form on their own, outside planetary systems. According to NASA, a study suggested that when NASA's Nancy Grace Roman Space Telescope comes online, it could spot as many as 400 Earth-mass rogue exoplanets using microlensing. Discovering exoplanets is tricky because, unlike stars, they don't emit their own light, or at least not enough to help locate them. This means that most techniques exoplanet hunters use to discover exoplanets are related to spotting the effects a planet has on its parent star. Subscribe to my channel if you want to learn more about aliens and exoplanets. See you in the next video.